Hello everyone and welcome to MJ's Maths and Stats. I'm Mohit Jain, your host, your dost, and today in a host mode. Today we will check out questions on numbers. These questions have been accumulated with previous year question papers of different companies and competitive examination. So let's begin volume 6.1, question number 5012550. Let x, y, z be distinct prime numbers. Which of the following statement can never be true? See, in these kind of questions where we need to identify which of the option is correct, it's always feasible. Let's take up few numbers. So let me take up 2, 3 and 5 to start with. X, y, z, and check quickly. X minus y is 1, 1 square is 1, 1 into z is 5, that is odd. X minus y is minus 1, z minus x is 3, and y minus z is minus 2. Again, this is not odd. X plus z is 7 into y square is odd. X square minus y square, 4 minus 9 is 5 into 5, that is odd. We are getting two statement as correct if we take 2, 3, 5. Now if we take 3, 5, 7, then x minus y 2, 4, 4 into 7 is even. Okay, and the second one would be x minus y is 2, z minus x is 4, and since we are multiplying and one of the number is 2, it will be even again. X plus z is 10 and this will be even. So we can see that option A may be odd or even, option B may be even or odd, option C is always odd whatever pair of prime numbers we take, but option B is never odd. So which of the following statement can never be true is option B. The number 445, which is in decimal system, is equals to A, another number in base system 6. That means we need to convert this from decimal system to base system 6, and the process is just keep on dividing by 6. 7 times 42, 25, 4 times remainder 1, then again divide by 6, 1 and 2, 12, remainder would be 2, again divide by 6 2 times and 0. As the remainder we need to stop here because we can't divide 2 further. Now from below to top we'll write this number from left to right. So this will be 2021 in base system 6. 2021 fits in option B. A number nearest to 16438 that is exactly divisible by 11 as well as 7. A number is divisible by 7 and 11, that means it is divisible by 77. We are looking out for multiple of 77 which is close to 16438. Let's divide. Twice would be 154, 103, 1 times 77, 6 and 2, 8, I guess 3 times 1, 2, 21 and 2, 23. So we'll get 37 as the remainder. Now 16438 minus 37 is 16401, and if you add 77 to this, it will become 16478. Now which of these two number is near to the given number? Obviously 16401, because the distance between 16401 and the given number is 37, but the given number and this number distance is 40. We are looking out for the nearest. Answer is 16401, option B. If 45376A is divisible by 3, now what is divisibility rule of 3? That sum of digits should be divisible by 3. So 459 gone, 10, 16. If it is 16, what should be the value of A, the smallest value of A, such that it become divisible by 3? That is 18. A should be equals to 2. Option A. What is the sum of all the 2-digit numbers which when divided by 5 leaves remainder 2? Stop. I need all 2-digit number which when divided by 5 leaves remainder 2. The smallest of such would be 12, 10 plus 2, and biggest of the 2-digit number would be 95 plus 2, that is 97, and the common difference would be 5. So how many numbers are there? We will use the direct formula, L equals to 97 minus 12 by 5 plus 1, that is 85 by 5 plus 1, 17 plus 1, 18. So sum of these numbers would be 18 by 2 into A plus L. That would be 9 into 109. 9 into 109 is 981. Okay. Second part. Or when divided by 6 leaves remainder 3. Okay. So first number would be 15. 12 plus 3 is 15. And the last number which when divided by 6 leaves remainder 3 would be 96 plus 3, that is 99, with common difference of 6. Then how many numbers are there? 99 minus 15 by 6 plus 1, that is 84 by 6 plus 1. 84 by 6 is 14 plus 1 is 15. So its total would be 15 by 2 into 15 plus 99, that is 15 by 2 into 114, that is 57. 15 into 57 is 855. Now we are not supposed to add these two up. Why? Because there can be some numbers which are common to these two types of numbers also. What are those kind of numbers? Those kind of numbers are those number which are divisible by 5 and 6, that is 30, and leaves remainder 2 when divided by 5, leaves remainder 3 when divided by 6. Now please see the concept of residue. When you divide a number by 5, remainder is 2. What is 5 minus 2? That is 3. And when you divide a number by 6, its leaves remainder 3. What is 6 minus 3? 3. This is known as residue. So the common number which is divisible by 5 and leaving remainder 2, and when divided by 6 leaves remainder 3, would be in the form of 30k minus 3. When the residue is same, we deduct that residue from that number order. Now we need to identify those numbers which are in the form of 30k minus 3. That would be, if I put k equals to 127, then it would be 57, and then it would be 87. There are only 3 2-digit numbers which are divisible by 5, divisible by 6, by leaving remainder 2 and 3 respectively. That means these are the 3 common numbers. Now what is the total of 27 plus 57 plus 87? That is 171. That means my required answer is 981 plus 855 minus 171. That should give me 5 at the end, 1665. The number 194, which is decimal number system, okay, is equals to 1, 2, 3, 4 in base A. What can be base A? It is 1, 2, 3, 4. That means base is more than 4. Base has to be more than 4. I can eliminate 2 and 3. I'm stuck to 7 and 5. And then let me convert this into base 10. It would be 0, 1, 2, 3. That is A cube plus 2A square plus 3A plus 4. Let me start with 5. 5 cube is 125. 5 square 25 into 2 is 50. 5 into 3 is 15 and 4. That gives me 10, 14, 1, 5, 6, 7, 8, 9, 194. Bingo. Answer is B5. Question number 507 and 508. A teacher writes a number on the blackboard and the students make the following observations regarding the number. Number is a 4-digit number, A, B, C, D. The sum of the digits A plus B plus C plus D equals product A into B into C into D. Wonderful. The number is divisible by A, B, C, D is divisible by sum of the digits. Let's see. What are the question asked? What is the sum of the digits of the number? Okay. And the number written by the teacher on the blackboard is, and the 4 options are given. We shall start with this, isn't it? Okay, A plus B plus C plus D should be A into B into C into D. 4 plus 2, 6 plus 1 is 8, and 4 into 8 is 8, matching. 2, 2, 2, 6 plus 4 is 10, but when you multiply it is not 10. 4 into 1, 1, 1, 2 is 8, and sum is also 8 and product is also 8, matching. 2, 2, 4 and into 4 is 16 into 2 is 32, but when we add up it is 10. So either it is A or it is C. Let me see the next condition. Number is divisible by sum of the digits. Okay, number is divisible by sum. Sum is 8. Is this number divisible by 8? Last 3 number I need to check. 112 by 8. 1 times and 32. Yes, this number is divisible by 8. Is this number divisible by 8? 124. No. That means by option elimination we get the number as 4112. That is option C. Now we can answer question number 507. The sum of the digits of the number is 8. So for 507 and 508, option C is the answer. What is the sum of all 2-digit numbers which will leave a remainder of 6 when divided by 8? That means we are looking out for this type of number. 2-digit divided by 8, 16 plus 6. I think 22 is the smallest 2-digit number. No, 8 plus 6 is 14. That should be the smallest 4-digit number. Now 100 by 8, 96, but 96 plus 6 would be 102. Let me subtract 8, so it should be 94. 94 when divided by 8, it leaves remainder 6. Okay, so we have this range now. Now common difference is 8. We know we need number of terms, that would be L minus A by D plus 1. 94 minus 14 by 8 plus 1, that is 10 plus 1 gives me 11. So the sum would be 11 by 2 into A plus L, that is 11 by 2 into 108. 54 into 11 would be 594. Option A. Find the number of positive integers which divide 2010 and leave a remainder of 10. This is a very tricky question. 2010 leaving remainder 10. That means 2010 is divisible by all such numbers which we are looking out for. Now what are these all such numbers? All such numbers are nothing but factors of 2000. Now we know the drill for the number of factors. If n can be written as p1 to the power a 1 into p2 to the power a2 into p3 to the power a3, where p stands for prime factors, then number of factors are given by, number of factors are a1 plus 1 into a2 plus 1 into a3 plus 1 and on. Now how I can write 2000 as 2002 into 10 to the power 3, so it will be 2 to the power 4 into 5 to the power 3. Number of factors of 2000 are 4 plus 1 into 3 plus 1, that is 5 into 4, that is 20. Okay, now if I want to write that how many if I want to write that what are these factors, it would be 1, 2, 4, 5, 2 cube is there 8, 5 into 2 is there 10, and on and on and on till 2000 we will have 20 factors. Now what is the question? Find the number of positive integers. Okay, we have got these positive integers which are 20 in numbers, which divide 2010 and leave a remainder of 10. But when I divide 2010 by 1, it is not leaving remainder 10. By 2, it is not leaving remainder 10. Okay, when I divide it by 4, it is not leaving remainder 10. By 5, it is fully divisible. By 8, no remainder 10. By 10, no remainder 10. After 10, if I see, my next is 2 to the power 4, that is 16. If I divide 2010 by 16, it leaves remainder 10. That means what? What is the concept behind it? We are looking out for factors of 2000 which are greater than 10. Which are greater than 10. So out of 20 factors, 1, 2, 3, 4, 5, 6, 6 factors we need to deduct. 20 minus 6 is 14. So there are 14 positive integers which will divide 2010 and leave a remainder of 10. A number when divided by 162 leaves remainder 21. That means this number is 162q plus 21, where q is the quotient. If the same number is divided by 18, what is the remainder? I can see that 162 is divisible by 18 9 times. That means this entire portion is divisible by 18. Now the remainder would be simply when 21 is divided by 18, and that is 3. Option B. What is the highest power of 5? 5 is prime number, we know that, which divides this expression without leaving remainder 0. That means we are looking out for the highest power of 5 which can divide this expression. We know the drill for factorial n, that when factorial n is divided by p to the power x, we know the drill. But this is no factorial. Now can we convert this into factorial? Can I write this as 1 into 2 into 3 till 1000 into 1001 till 2010 divided by 1 into 2 into 3 till 1000, isn't it? This portion will get cancelled out, and ultimately we will end up getting our expression. Why I have written like this? Because I need factorials. I know the drill with factorials and no other numbers. So this is 1 till 2010, that is factorial 2010, by 1 till 1000, that is factorial 1000. Now I know the drill. And what's that? We need to find the highest power of 5 which can divide 2010. It's simply keep on dividing this by 5. 402, again divide by 5. 80, 16, 3. Now just add up. 6, 3, 9, 2, 1, 11, 1, 0. 501. Okay, that means factorial 2010 is completely divisible by 5 to the power 501. Now we use the same process for factorial 100. Let's divide 100 by 5. 200, 40, then 8, and then 1. 249. Factorial 1000 is perfectly divisible by 5 to the power 249. That means our expression is fully divisible by 5 to the power 501 minus 249. That will give us 5 to the power 252. Option B fits in. Gargi receives message from 3 different person A, B, C every 6 minutes, 8 minutes and 12 minutes. I think it is a sum of LCM. If she receives all the 3 messages at 10:30 am, then which of the following is the time at which she receives all the 3 messages? Great. What is LCM of 6, 8, 12 is 24. 24 minutes is the LCM. That means after every 24 minutes, Gargi will receive all the 3 messages together. Again 24, 12:30 p.m. One of the options fits in. In how many ways can 5 to the power 11 be expressed as a product of 3 factors? But as a product of 3 factors we need. That means 5 to the power a into 5 to the power b into 5 to the power c should be equals to 5 to the power 11. That means a plus b plus c should be equals to 11. Now let's pick up cases. Here value of a can also be 0 because 5 to the power 0 is 1, which is also one of the factor. So if I take a as 0, what can be the combination I can have for b and c? 0, 11, 1, 10, 2, 9, 3, 8, 4, 7, 5, 6. I'm not writing 6, 5 because again I'll end up getting the same thing. So we can have b and c in 1, 2, 3, 4, 5, 6. 6 ways. So we have 0, 1, 10. All totals gives us 11. Now let's take a as 1. If I take a as 1, I'm left with what? 10. 5 ways. You will start seeing a pattern. If a is 2, that okay, 218 already captured here in 218. That is also out. So it should be 3 ways. Great. If a is equals to 3, so only in 2 ways we can have this. Now if a is equals to 4, 5 to the power 4, then because already we have taken up these cases, so no more further dealing. So total number of cases would be 6 plus 5 plus 3 plus 2. 6 and 10 is 16. Mohit Jain writes a number 458 on the blackboard. After has, that means we are looking out for number of minimum steps in which we can convert this 458 into 14. Assume that no friend walks up to the board twice. Exactly, that is our assumption. Let's try. So first one come and delete number 8, second one doubles is to 90, third one also doubles to 180, fourth double to 360, fifth again double it to 720, sixth came and delete 0, then seventh came and delete 2, and then eighth came and doubled it. 8 minimum steps would be required. That means Mohit Jain have got 8 friends in that particular room at that particular point of time. Option C. A number when divided by 4, 5, 6, 7 leaves remainder 2, 3, 4, 5, all different remainders. But see one thing, 4 minus 2 is 2, 5 minus 3 is 2, 6 minus 4 is 2, 7 minus 5 is 2. That means in this case residue is same, and we know the drill. First find the LCM of 4, 5, 6, 7. So LCM is 420. What is the largest such number less than 3000? Okay, let's divide 3000 by 420 quickly. There would be 60. That means 3000 minus 60 is 2940. This 2940 is divisible by 4, divisible by 5, divisible by 6, and divisible by 7. But here the residue is 2, and whenever residue is same, we deduct that residue from that common multiple. So our required number is 2938. Option B fits in. Find the number of 3-digit numbers. 3-digit number this time, which when divided by 7 and 5 leaves remainder 2. Okay, common remainder. Divided by 7 and 5, here it is written and, that means 7 into 5, that is 35. We are looking out for multiples of 35. That means number would be in the form of 35k plus 2 because we have a common remainder 2. Now let us try to identify the first 3-digit number. So this is our A, this is our L, and common difference is 35. Then we are looking out for N, and we know the formula for N. L minus A by D plus 1. So there are 26 three-digit numbers. Option B. The remainder of the square of any prime number greater than 5 when divided by 24. Let's check with the number. 7 is square, 49 divided by 24, remainder is 1. 11 is square, 121 divided by 24, remainder is 1. P is square, for p greater than 5, p is square when divided by 24 always leaves remainder 1. How many three-digit numbers have the product of their digits a into b into c as a perfect square? Okay, this is a square number, as well as perfect cube greater than 0. Now, if we see, we know that the maximum value that a can take is 9, and here the minimum value would be 1, because product is not 0. That means none of the digit is 0. Now we need to try to identify what can be the values of a, b, c, or we need to try to identify those numbers which are also square and cubes. Good. So first number which I can recollect is 1. 1 is also a square and 1 is also a cube. Then what can be the combination which will give me 1? That would be 1, 1, 1. Now in how many ways I can arrange this 3 digits? That is factorial 3 by factorial 3. That is one way, obviously 1, 1, 1. Now can we have some other number which is a square of some number and cube of some number? That is 64. 64 is 4 cube and 64 is 8 square. Now what different combination can give me 64 when multiplied? 1 into 8 into 8 is 64. Let me take up 2 from here. Then I will have 2 into 4 into 8 is also 64. Let me have 2 from here also and give it to this 2. Then I'll have 4 into 4 into 4. That is also 64. So 3 combination possible. Then in how many ways first combination would be arranged? Factorial 3 by factorial 2. That is 3 ways. The second combination can be arranged in factorial 3. That is 6 ways. And the third combination can be arranged in factorial 3 by factorial 3. That is 1 way. So we have 10 ways of getting product 64. It can be 188 or 818, 881. You know the drill for permutation. Now the next would be 999. That is 729. 729 is 9 cube, which is 3 to the power 6, or we can say 3 cube whole square. Isn't it? 27 whole square is also 729. This can be 9 into 9 into 9, and again factorial 3 by factorial 3. That is one combination, one arrangement. In one way they can arrange themselves. So we have 10 plus 1 plus 1. That gives us 12 ways. Or there are 12 three-digit numbers whose product of the digits are perfect square and perfect cube also, greater than 0. Find the smallest prime number dividing the sum 3 to the power 11 plus 5 to the power 13. Bingo. 3 to the power any power would be an odd number, and 5 to the power any power is also always an odd number. Now odd number plus odd number is always an even number. That means sum has to be an even number, and if it is an even number, it is divisible by 2, and 2 is the smallest prime number. Option A. Find the number of odd factors of 4312. We know the drill for number of factors. We have explained this in one of the question before also. Let's first find the prime factor of 4312. 7 times and again 7 and then 7, 11. So 4312 is 2 to the power 3 into 7 to the power 2 into 11 to the power 1. Prime factor 2 and its power, and use the same formula. So number of odd factors are 2 plus 1 into 1 plus 1. 3 into 2 is 6. The sum of two numbers is 528, and the HCF is 33. That means the two numbers are 33x and 33y. The two numbers are 33x and 33y, and sum of these two numbers is 528. That means x plus y is 528 by 33. Okay, 11, 3, 11 is 4, 8, that is 16. And x, y are co-primes, isn't it? They need to be relatively prime number, or else HCF won't be 33. Now we just need to identify the values of x and y such that x plus y is 16 and x and y are co-primes. I can take 115. HCF of 115 is 1. That means 1 and 15 are co-primes. With 2 is 14, 3 is 13. 3, 13 co-primes. 4, not 5, 5, 11. We can have 5, 11. Then 6, 10, 7, 7. We can have 7, 9. Yes, fine. We can't have 8, 8. And then again we will end up getting 9, 7, which is again the same thing. So we can have 4 pairs. How many such pairs of numbers are possible? 4 pairs of numbers are possible such that their HCF is 33 and sum is 528. Option C. Find the number of digits in the expansion of 8 to the power 11 into 5 to the power 24. Now 8 is 2 to the power 3. So that will be 2 to the power 3 to the power 11, 2 to the power 33. Into 5 to the power 24. Now can I write this as, if I give 24 powers of 2, I'm left with 2 to the power 9. 2 to the power 9 into 2 to the power 24 into 5 to the power 24. That is 2 to the power 9 into 10 to the power 24. And 2 to the power 9 is 512 into 10 to the power 24. That means what? This is a number which starts with 512 and after that we have got 24 zeros. So this number is 24 plus 3, that is 27 digits number. Find the maximum value of x for which factorial 21 is completely divisible by 2 to the power x. And we know the drill that when factorial n is divided by prime number to the power x, we just keep on dividing n by p and count on the coefficients, isn't it? So 21 when divided by 2 gives 10, divided by 2 5 times, and again divided by 2 2 times. Again we'll divide this by 2, 1. Keep on dividing till you reach a number which is smaller than the divisor. Now 10 plus 5, 15, 16, 17 and 1, 18. That means factorial 21 is completely divisible by 2 to the power 18. Option B fits in. The positive integer n has exactly 12 distinct positive divisors, including 1 and itself. Number of factors are 12. But only 3 distinct prime factors. That means this number n is p1 to the power a into p2 to the power b into p3 to the power c, because it's given only 3 distinct prime factors. If the sum of these prime factors is 20, that means p1 plus p2 plus p3 is 20, then compute the smallest possible value of n. Now we have got p1 plus p2 plus p3 is 20, and one more equation we have, a plus 1 into b plus 1 into c plus 1 is equals to 12. Now we are looking out for the smallest number. Let me assume that out of these 3 factors, one of the prime numbers is 2, because we are looking out for the smallest number. So maybe like we have 2 here. So if p1 is taken as 2, then p2 plus p3 is 18. Then what combination of prime numbers will give me 18? 3, 15, no. Then we have 5, 13. 5, 13 will give me 18. And then 7, 11. 7 11 will give me 18. That's it. So my number could be 2 to the power a into 5 to the power b into 13 to the power c, or 2 to the power a into 7 to the power b into 11 to the power c. Again, if we multiply three numbers, we are getting 12. Now 12 can be like 1 into 2 into 6, but none of these number can be 1. Yes, because it is a plus 1, a cannot be 0. So we can have 2 into 2, 4 into 3. Now to give the maximum power to 2, that should be our aim, to get the smallest number. So let me have a plus 1 equals to 3. So a is 2, b on equating will give me 1, and c on equating will give me 1. So my number would be 2 to the power 2 into 5 to the power 1 into 13 to the power 1. 13 into 5 is 65. 65 into 4 is 260. Or 2 to the power 2 into 7 to the power 1 into 11 to the power 1. Anytime 77 is greater than 65, that means the smallest of the number which we are looking out for is 260. The natural numbers from 1 to 4000 are written on a paper. The numbers in the odd places are cancelled. Remember, we are cancelling the numbers which are on the odd places and not necessarily the odd number. But here, and the remaining set of numbers are written back. From these numbers, again the numbers in the odd places are cancelled and the remaining set of numbers are written back. This process is continued until a single number, say a, is left. Find the number a. Obviously, it's not easy for us to write all the numbers and try to identify. I'll always advise you to go in with 10 numbers first. And if you can identify a process with 10 numbers, believe me, that process would be applicable for the entire numbers. So let us have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. On first round, the odd place will always start with 1. 1, 3, 5, 7, 9 gone. So now we are left with 2, 4, 6, 8, 10. Odd place is 1, 3, 5 gone. We're left with 4, 8. Odd place is 4 gone. 8. Now what kind of character is 8? What is 8? 8 is 2 cube. Now, can I say 2 cube is the largest power of 2 which is less than 10? Yes. That is the trick we are looking out for in this particular question. We are just looking out for highest power of 2 which is just less than 4000. We know 2 to the power 10 is 1024, 2 to the power 11 is 2048, but 2 to the power 12 is greater than 4000. So highest power of 2 contained in 4000 is 2 to the power 11, and that is 2048. That will be the number which will remain intact till the end. I hope you have read the question, and let's see what it is. A student was asked to add first few natural numbers so long his patience permitted. The student stops adding and gave the number as 600. When the teacher declared the result was wrong, the student found that he had missed one number during the addition. Find the number missed. Means 1 plus 2 plus 3 till n is n into n plus 1 by 2. That is given wrong. That means suppose if k is missing, then n into n plus 1 by 2 minus k is equals to 600. That is being given by student. Now you may use hit and trial and put the value, what can be the n near to 600, and then you may try. But believe me, we have a scientific method to solve this, and how it is nothing but using triangular numbers concept. Sum is 600. Just multiply this by 2. That is 1200. Find the square root of 1200. We know that 35 square is 1225, which is just greater than 1200. So we may take the value 35. Now just find n into n plus 1 by 2 by taking the value 35. It would be 35 into 36 by 2. How much is 35 into 18? Anyone? How much is 35 into 18? 630. That means what? 630 should be the total what this student is supposed to give, but he have given the total 600. Then the number that is missed out is 630 minus 600, that is 30. Okay, so let the least possible number be x. So we have 2010 into 2011. So if I take this as a, this is a into a plus 1, that is a square plus a. That means if from a square plus a I deduct a, then I'll get a square, isn't it? That my answer is a. I need to deduct a to get a square number. Now what was a? A was 2010. So least positive integer is 2010, which need to be subtracted from 2010 into 2011 to get us a square number. Option D. How many times the keys of a computer keyboard be pressed to type the numbers from 1 to 100? Now, very simple pattern which we can use. How many numbers are there from 00 to 99? If we look carefully, from 00 to 99 we have got 100 numbers, and each number are of 2 digits. That means I need 200 digits to type 00 to 99. But I am typing 1. I have started typing from 1. That means 2 zeros won't be there. And again from 1 to 9 I am typing 1 to 9 only, not 01, 02 till 09. That means 9 digits gone, not required. And to type 100 I require 3 more digits, isn't it? So the total number of times I need to press keys would be 200 minus 11 plus 3, that is 192. The sum of all odd numbers starting from 1 to at the greatest 4-digit number. Again, a property based straight question. Now what is the property? Property is 1 plus 3 plus 5 plus 7 till nth term. Suppose this is also an odd number, and nth odd number is nothing but n square. Okay, so number of terms in this series is L minus A by D plus 1. 9999 minus 1 is 9998 by 2 would be 4999 plus 1. That is, it is the 5000, isn't it? Yes, it was simple. From 1 to 10,000 we have 10,000 numbers. 10,000 by 2 is odd, 10,000 by 2 is even. That is also the logic. 5,000 odd numbers are there. That means what would be the sum? Sum would be nothing but 5,000 whole square. The HCF of two numbers is 15. Let the number be 15x, 15y. How many such pairs of number lies between 25 and 100? Now 25 by 15, that means if I take the higher upper boundary is 2, the number should be 30 at least, and 100 by 15 is 96. That means if I am choosing what can be x and y, two conditions are with me. X, y are co-primes, and the value of x and y lies between 2 to 6. So let us find that how many pairs we can have with x and y which are co-primes and the values lies between 2 to 6. So if I start with 2, it can be 2, 3 co-primes, it can be 2, 5 co-primes. If I take 3, 3, 2 is already there, 3, 5, 3, 4, 3, 4 is co-prime, 3, 5 is also co-prime, not 3, 6. Then with 4, 4, 2, 4, 3 not acceptable, 4, 5 are co-prime, and 4, 6 is not co-prime. Now with the 5 I can have 5, 6, and then with 6 nothing I can have because 6, 5 is already taken up. So 1, 2, 3, 4, 5, 6. 6 pairs. 6. Which of the following number is a factor of 14641? Now, is a factor of 14641? That means we are looking out for divisibility rule, isn't it? Okay. What is divisibility rule for 3? Sum of digits. 10, 14, 15, 16. No, it is not divisible by 3. 10, 14, 15, 16. It is not divisible by 9 either. Divisibility rule for 11. We'll add the odd place digit and even place digit. 1 plus 6 is 7 plus 1 is 8. And 8 and 8 is also... And 4 and 4 is 8. So 8 minus 8 is 0. Bingo. This number is divisible by 11. Find the number of even factors, and I think we have discussed even factors, odd factors in detail in previous 2 questions also for this number. But mind it, this number need to be written in the form of prime numbers, prime factors, as we can see that 2, 3, 5, 7 are prime numbers, but 10 is not a prime number. That is 2 to the power 2 into 5 to the power 2. So actually my n is 2 to the power 9 into 3 to the power 5 into 5 to the power 4 plus 2 is 6 into 7 to the power 3. This is my number. Okay, so number of even factors would be power of 2 taken up as it is, and then powers of other prime numbers to be taken with plus 1. That is 5 plus 1 into 6 plus 1 into 3 plus 1. That will be 9 into 6 into 7 into 4. 1512. Answer. In how many ways you can write 360 as a product of 2 co-primes? A simple concept again which we can use to find these kind of questions. First, 2 to the power 3 into 3 to the power 2 into 5 to the power 1. So we have n which is written in this form. 360 written in the form of p1 to the power a plus into p2 to the power b into dot dot dot. Now, how many prime factors are there? 3. Suppose n number of prime factors are there. For a given n, we have got p prime factors. Then, number of ways in which we can write given number n as a product of 2 co-primes is just given by 2 to the power n minus 1 ways. In case of 360, if we can see, we have got 3 prime factors. So number of ways in which we can write 360 as product of 2 co-primes would be 2 to the power 3 minus 1. That is 2 to the power 2. That is 4. How many numbers less than 20 are co-prime to 20? So less than 20, let's have all the numbers less than 20. Now, out of these 19 numbers, how many numbers are prime to 20? Can we find that? 1 is prime to 20, 2 not, 3 is prime to 20, not 4, not 5, 6 no, common, 7 is prime, 8 no, 9 is prime, not 10, 11 is prime with 20, 12 not, 13 is prime with 20, not 14, not 15, not even 16, 17 is prime to 20, not 18, 19. So we'll have 1, 2, 3, 4, 5, 6, 7, 8, and we will say that answer is 8. But what if this is not 20, this is 210, this is 1, 2, something, something, something. Obviously, we should have some specific process to identify it. And to find this is nothing but we need to find the totient number of 20. Okay. Now, what do you mean by the totient number? Suppose 20 is what? What is 20? 4 into 5, that is 2 square into 5 to the power 1. Then 2 and 5 are the prime factors of 20. Then totient number of any number is given by number into 1 minus 1 by p1 into 1 minus 1 by p2 into 1 minus 1 by p3 and on. In this case, we have got 2 prime factor, that is 2 and 5. So totient number of 20 is 20 into 1 minus 1 by 2 into 1 minus 1 by 5. That will give us 20 into half into 4 by 5. 2 times 10, 5, 2, and that is 8. Bingo. That is the answer. Find the remainder when 3 to the power 5555 plus 2 to the power 4444 is divided by 7. Can I write this as 3 to the power 5 to the power 1111 plus 2 to the power 4 to the power 1111, isn't it? Now how much is 3 to the power 5? 3 to the power 5 is 243 to the power 1111 plus 2 to the power 4 is 16 to the power 1111. Means this is 243 to the power a plus 16 to the power a, where a is odd. And we know that a to the power n plus b to the power n is divisible by a plus b if n is odd. We know that. Okay, that means 243 to the power a plus 16 to the power a, where a is odd, is have a factor 243 plus 16. That means it is divisible by 243 plus 16, that is 259. Now, is 259 divisible by 7? 259 when divided by 7, it is 3 times and 49. Yes, 259 is divisible by 7. That means 259 is factor of this number and 259 is divisible by 7. That means the entire number is divisible by 7. So the remainder which we are looking out for is 0. How many numbers less than 1000 have exactly 3 factors? Fact which we need to know. Only square of prime numbers will have exactly 3 factors. Now, till 1000, how many prime number squares are there? Okay, so 31 is square is 961. We can't go beyond that. So how many prime numbers are there from 1 to 31? We have got 2, 3, 5, 7, 11, 13, 17, 19, 23, 29 and 31. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. X plus y is 999, where both x and y are prime numbers. How many such pairs of x comma y are possible? If we see x plus y is odd, when we can have sum of two numbers at odd? It is only possible when one of the number is even and one of the number is odd. Why? Because if both are odd, then the sum should end up in even, and if both are even, sum should also end up with even number. But sum is odd, that means one of the number is even and one of the number is odd. Now we know that x and y both are prime numbers and x is even. That is only possible when x is equals to 2, because 2 is the only even prime number. Now if x is equals to 2, y should be equals to 997. Now we need to know that whether 997 is a prime number or not. Yes, 997 is the highest 3-digit prime number. That means the case of 2 plus 997 is possible. The case of 997 plus 2 is also possible. So how many such pairs of x comma y are possible? Answer 2. If 25 is written as 100 in some number system, I'll stop here. 25, as I see, is 5 square, and it is written as 100 in some number system. That simply means that we are dealing with number system 5, because we know that any number is written as 100 in its own number system. Like 10 is written as 10, like 10 square is written as 100 in number system 10. Similarly, 3 square, that is 9, would be written as 100 in number system 3. So we are dealing with number system 5. How will 24 be written as in the same number system? 24 need to be written in number system 5. Just divide by 5, we will get what? 4 and remainder 4. That means 24 in base 10 is written as 44 in base 5. Answer. The difference of two numbers is 1365. Let me take x is greater than y. Then x minus y is 1365. On dividing the larger number, that is x, by y, we get 6 as quotient and 15 as remainder. That means x is equals to 6y plus 15. Just solve these two equations, isn't it? So x is 6y plus 15 minus y is 1365. 5y equals 1350. Y equals 1350 by 5, that would be 270. And y is the smaller number. Find the smaller number. Smaller number is 270. Find the least length of cloth which has to be measured exact number of times using any of 3 measuring rods of length 12 centimeter, 15 centimeter and 20 centimeter. Common multiple, isn't it? Answer is simply LCM of 12, 15 and 20. That is 60. The HCF and LCM of two numbers is 18 and 180 respectively. If one of the number is 36, then find the other number. We know the drill for HCF LCM. Product of two numbers is given by product of their HCF and LCM. So other number is 18 into 180 divided by 360, that is 90. Find the number just greater than 5000 which when divided by 2, 3, 4, 5, 6, 7, 8 and 9 leaves remainder 1 in all cases. We know that when we have divisors and remainder is same in all the cases, we just need to find the LCM first. LCM of 2, 3, 4, 5, 6, 7, 8, 9 would be 2520. Then we need to take this LCM to this number as close as possible, which I can see is if I multiply by 2, this number would be near to 5000. So that would be 5040. So 5040 is a number which is just greater than 5000 and divisible by 2, 3, 4, 5, 6, 7, 8, 9. But we are looking out for remainder 1. Just add the common remainder to it. Number required is 5041. Find the number of zeros at the end of the expression 5 into 10 into 95 till 100. If we look carefully, can I write this 5 as 5 into 1, this 10 is 5 into 2, 95 is 5 into 19 and 100 is 5 into 20. So this expression is nothing but 5 to the power 20 into factorial 20. Now see what is asked. Find the number of zeros at the end of this. To get the number of zeros, we need how many times this number can be divisible by 10. To find the number of zeros, we need to find how many times this number would be divisible by 10, isn't it? Okay, so for 10, we need 5s and we need 2s. So how many times factorial 20 is divisible by 5? We know the drill for that. That is 4 times only. And how many times factorial 20 is divisible by 2? We have the drill of 10. Then what do we have? 5. 5 divided by 2 is 2. And then 1. So that is 18. That means what? This entire expression is divisible by 5 to the power 20 and 5 to the power 4. And this is also divisible by 2 to the power 18. That means it is divisible by 5 to the power 24 and it is divisible by 2 to the power 18. Can I conclude that this is divisible by 10 to the power 18? Because with 24 5s and 18 2s, we can have only 18 pairs of 10. The given expression is divisible by 10 to the power 18. Number of zeros at the end of this expression are 18. And A such that 2, 3A, 4, 1 is divisible by 7. Good. What is the divisibility rule for 7? We use the code -1, 2, 3, then 1 minus 2 minus 3 to check whether the number is divisible by 7 or not. How to use it? Start writing this code from left to right. on top of these digits. -1, 2, 3, and then 1, -2. Multiply these digits with its coefficient on the top and add up. -2 plus 6 plus 3a plus 4 minus 2. So 10 minus 2, this is 3a plus 6. Now this 3a plus 6 should be divisible by 7. So what should be the value of a? So if I take a equals to 5, I'll have 3 into 5, 15 plus 6, that is 21, that is divisible by 7. A is equals to 5. Now 5 plus 7 is 12, we can't go further. 5 minus 7 is -2, we can't go down. That means only possible value is 5. A number 774958A 96B is divisible by 72. 72 is a composite number. We know that. Now, to check whether a number is divisible by 72 or not, we need to check divisibility with two other numbers. First is 8 and 9. Rule for 8 is last 3 digits should be divisible by 8, and rule for 9 is sum of digits should be divisible by 9. So let us first check for last 3 digits. Last 3 digits are 96B. Okay. So what can be the value of B so that 96B is divisible by 8? 96 is divisible by 8. We can have B equals to 0. We can have B equals to 8. Done. Now we'll go and check for 9. So to check whether the number is divisible by 9 or not, let's just add these digits. 14 plus 4 is 18, gone. 9 gone. 5 and 8 is 13. That we are left with. 1 plus 3 is 4. 4 plus 6 is 10. That is 1. 1 plus 9 is 10 again. That is 1. That means A plus B plus 1 should be divisible by 9. If I call it 9, then A plus B is 8. B is 0. Fine. Then A should be 8. We can have answer 8, 0. If B is 8, we can have A as 0. We can have answer 0, 8 also. Okay. Can we have this total as another multiple of 9? That is 18. Then 18 minus 1 would be 17. Then in that case, A plus B would be 17. And we have only option left with B is highest value 8. Then A plus 8 is 17. That means A is equals to 9. 9 comma 8 is also possible. Then find the value of A and B respectively. We can have 3 possible sets for A and B. A number is formed by writing the first 24 natural numbers. What will be the remainder if this number is divided by 9? We need to just find sum of digits. Okay, not required to add up all. Just use some concept. 1 to 9, we know the total is 45. Now when we are looking at 10 to 19, we can see that we have 1 coming on the odd places. How many times? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So next total would be 1 into 10, that is 10. Now again we are left with 1, 2, 3, 4, 5, 6, 7, 8, 9. Total till 9 is 45. Add up. Come up here. 2 we have 1, 2, 3, 4, 5. So that is 2 into 5 is 10. And now we have 1 plus 2 plus 3 plus 4. 4, 3, 7 and 3 is 10 again. So this is the sum of digits. 90, 100 and 120. So what is the remainder if this number is divided by 9? Now just keep on adding these digits again. 1 plus 2 plus 0 is 3. Remainder is 3. Answer. Find the unit digit of the expression. Great. 251 to the power 98. We just need to look at the last digit of these number. That's it to find the unit digit, isn't it? 1 to power anything will always end with 1. 1 to the power anything will always end with 1. 6 to the power anything always ends with 6. 5 to the power anything always ends with 5. 6 to the power anything always ends with 6, and the last digit of this number is 9. So we have 9, 10, 15 and 1 16 minus 12, that is 4, last digit. What is the last non-zero digit of the number 30 to the power 2720? Suppose we have a number 10340000. If we delete all the zeros, this is known as last non-zero digit. Okay, we are also looking out for something like that. Now that means I need to first cancel out all the zeros at the end. So this number can be written as 3 to the power 2720 into 10 to the power 2720. That means this will have a significant digit which is not a 0, obviously it is 3, and after that we will have 2720 zeros. To leave it, we just need to find last digit of 3 to the power 2720. Now what is the rule to find last digit of 3 to the power anything? Rule is simple, just divide power or the index by 4 and find the remainder. So when I divide 2720 by 4, I get remainder 0. And the rule is, if you get remainder 0, your power will become 4. If you get remainder 1, your power will become 1. If you get remainder 2, your power will become 2. If you get remainder 3, your power will become 3. That is, the power cycle for 3 is of 4. That means we are looking out for last digit of 3 to the power 4. That's it. Now we know now what is 3 to the power 4. 3 to the power is 81. So last digit is 1. Find the digits in the thousands position: unit, 10, 100, 1000. That means from the right we are looking out for the fourth digits in the expansion of 5 to the power 3 into 2 to the power 1001. Now can I write this as 5 to the power 3 into 2 to the power 3 into 2 to the power 998? Yes, this is 2 to the power 998 into 10 to the power 3. That means at the end of this expression we will have 3 zeros. Bingo. These 3 digits we have. Now what will be the thousandth position digit? Thousandth position digit is nothing but last digit of 2 to the power 998. Isn't it? We are looking out for last digit of 2 to the power 998. Now what is the drill to find the last digit for 2 to the power n? The drill is same as what we did in our previous question for 3. Divide n by 4. That means when 998 is divided by 4, we have got remainder 2. Isn't it? Remainder is 2. 9 divided by 4 is 1, 18, 16, remainder 2. That means my power will reduce to 2 now. So last digit of 2 to the power 998 is nothing but last digit of 2 to the power 2. Now what is last digit of 2 to the power 2? That is 4. Thank you everyone. The reason we struggle with insecurity is because we compare our behind the scenes with everyone else highlight reel, isn't it? Stop comparing yourself with any other people. What you have, no other people in this universe have. Stick to your strength, your skill, and you will get what you deserve. Stay focused and believe in your purpose. With this best wishes, I'm Mohit Jain signing off from MJ's Maths and Stats. That's MJ Magic Studio to you. Subscribe to our channel and stay connected. I'll see you soon. Thank you.